Hi students, this is Alex here. In this video, we are going to find the Fourier series expansion for the given function f of x is equal to e power x in minus pi less than x less than pi of periodicity 2 pi. Let's check whether this given function is even function or odd function. So we take f of x, which is e power x. We have to find what is f of minus x. X is replaced as minus x. After replacing, we find this is not equal to f of x or it is not equal to minus f of x. So in this case, f of x is neither even nor odd. F of x is neither even nor odd function. Now next we are going to find a naught. A naught, the formula is 1 by pi integral minus pi to pi f of x dx, and this is 1 by pi integral minus pi to pi f of x is e power x dx. Integration of e power x is e power x itself, and we have to apply the limit minus pi to pi. When we apply the upper limit, we get e power pi minus, when we apply the lower limit, e power minus pi. This we can further rearrange as 1 by pi. E power pi is kept as it is, but this is written as 1 by e power pi. Then by taking LCM, we are going to get e power pi is the LCM, and here it is e power 2 pi minus 1. So finally we got a naught, which is 1, which is e power 2 pi minus 1 by pi e power pi. So we got a naught. In the similar way, we are going to find an. An equal to, by formula, it is 1 by pi integral minus pi to pi f of x into cos nx dx. We are going to replace f of x. So f of x is e power x into cos nx dx. We have a basic formula, integral e power ax into cos bx dx. This integration is e power ax by a square plus b square into a cos bx plus b sin bx, and we will have plus c, but now here we have a limit, so we don't use plus c. So this is 1 by pi e power a is 1 here, so e power x by 1 square plus b is n square, then 1 cos nx plus n sin nx. Then we have to apply the limit from minus pi till pi. When we substitute the upper limit, we are going to get e power pi by 1 plus n square into cos n pi plus n sin n pi. Then minus, when you apply the lower limit, e power minus pi by 1 plus n square into cos n into minus pi minus n into sin n of minus pi. Now finally, this becomes 1 by pi and e power pi by 1 plus n square into cos n pi is minus 1 whole power n and sin n pi is 0. Then coming to the second term, e power minus pi by 1 plus n square into, again cos n into minus pi is, minus is ignored inside the cos. So again this is going to be minus 1 whole power n and second term is 0. So here we can take the common terms 1 by n, and in the denominator 1 plus n square is taken common. In the numerator minus 1 whole power n is taken common. After taking common, we left with e power pi minus e power minus pi. Once again, this can be rearranged in the following way. So numerator minus 1 whole power n by pi into 1 plus n square. This is e power pi minus 1 by e power pi. Now we are going to take LCM, which we have done in the same way in A naught. So rest of the terms are written as it is. LCM is e power pi. Now this becomes e power 2 pi minus 1. So finally we got AN. The same way we are going to find BN. So coming to BN, the formula is BN equal to 1 by pi integral minus pi to pi f of x into sine nx dx. Now this becomes 1 by pi integral minus pi to pi f of x is e power x into sine nx dx. For this integration, we have a basic formula e power ax into sine bx dx is e power ax by a square plus b square into a sine bx minus b cos bx plus c. So here we don't use plus c because we have a limits. So this becomes 1 by pi integral minus pi to pi e power a is 1. So e power x, actually we are writing the formula, so no need to put the integral sign. 1 by pi bracket open e power x by a square is 1 square plus b square is n, and we have a sin bx, which is 1 sin nx minus n cos nx, and we have a limit minus pi till pi. Now substituting the limit, we are going to get 1 by pi e power pi by 1 plus n square, sin n pi is 0 and cos n pi is minus 1 whole power n. Then coming to the lower limit, e power minus pi by 1 plus n square, again sin n pi is 0, cos n pi will be minus 1 whole power n. Now we can take the common things out, 1 plus n square in the denominator, and in the numerator we have minus n into minus 1 whole power n, we can take common. So after that, the left out terms are e power pi minus e power minus pi. Now this can be further rearranged as minus n into minus 1 whole power n by pi into 1 plus n square, and here this is e power pi minus 1 by e power pi. We can take LCM here, and after rearranging minus n minus 1 whole power n by pi into 1 plus n square. This LCM is e power pi, so here it is e power 2 pi minus 1. So this is our Bn. After finding An and Bn and including the A naught, we are going to substitute this in the expansion formula. Fourier expansion f of x is A naught by 2 plus summation n is equal to 1 to infinity An cos nx plus summation n is equal to 1 to infinity Bn sin nx. Now this is A naught. A naught is e power 2 pi minus 1 by pi e power pi. So e power 2 pi minus 1 by pi e power pi by 2. So the by 2 we can write in the denominator, plus summation n is equal to 1 to infinity An cos nx. An is minus 1 whole power n by, let's write 1 by 1, minus 1 whole power n by pi into 1 plus n square, then e power 2 pi minus 1 by e power pi. So e power 2 pi minus 1 by e power pi cos nx, then plus summation n is equal to 1 to infinity Bn. Bn we have here minus n into minus 1 whole power n by pi into 1 plus n square. again e power 2 pi minus 1 by e power pi into sine nx. Then after this, throughout we have e power 2 pi minus 1 by pi e power pi common. So when that is taken common, the first term we left with 1 by 2. Then in the second term, this term will be taken common. So without that we have to write summation n is equal to 1 to infinity minus 1 whole power n by pi into 1 plus n square into cos nx, then plus summation n is equal to 1 to infinity minus n minus 1 whole power n by pi into 1 plus n square into sine nx. Then after this, we can also combine the last two terms by taking this 1 by 2 as it is. Then we can take this 1 by pi outside the summation in both. So 1 by pi I keep it outside. Actually that 1 by pi is also taken common here. So because this first term we had pi here, so including this pi we have taken common. So here no need to write in the next step. So we cancel this pi even here. So actually here nothing is common, only we can take the common summation for both the terms. So we have summation n is equal to 1 to infinity. First term is minus 1 whole power n by 1 plus n square. We have cos nx and sin nx with minus n. So we can combine that as together as cos nx minus n sin nx. So this is the required Fourier series expansion for the given function f of x equal to e power x.